Hey, so we're talking about vertical translations today. Okay, so vertical just means it's going up and down, and we're going to translate a line from the linear parent function where it goes through 0, 0 and has a slope of 1 to where it's moving up and down. Scratch that, stop here, cut this first part out. Take 2. Hey guys, so today we're talking about vertical translations of a line. Okay, we're going to write these linear equations in slope-intercept form using our slope and our y-intercept, but we're looking at what happens when we have different y-intercepts and how that affects the graph of the line. Okay, so in our previous video in Form 1, where we talked about slope-intercept form of equations, we talked about the linear parent function is y equals x. Okay, now in algebra, we also talk about function notation. And so in function notation, we can write this as f of x equals x. Now remember, y and f of x are the same thing. It's just a different way of writing it. F of x just names the equation, whereas y is just kind of a generic equation. Other linear functions can be created by changing our slope or our y-intercept, okay, of the parent function. So we're going to talk about changing the y-intercept today, okay? All right. First of all, let's graph the parent function. The parent function, I'm going to put in black here, our parent function is f of x equals x. So it starts with the y-intercept at 0. My slope is 1. M equals 1, b equals 0, okay? So because it's a slope of 1, that means we're going to go up 1 and right 1 to get to the next point. So I'm just going to go ahead and draw in my parent function for this line, for this example. And then I'll go ahead and do it on example 2 as well, because they're going to be the same. Okay. Once we get that here, we're going to connect all our points for our parent function. I'm going to go ahead and label this as f of x. Anytime you're going to put more than one line on a graph or more than one function on a graph, make sure you label your function. That way you could tell which function is which, especially if you're having to compare them later. So in this case, we're going to be comparing this graph that we're going to put two linear functions on one graph, and so we want to be able to compare those. So again, we want to make sure we start with our parent function, and then we will put our we'll put our transformation function up here. So we're going to do a different line this time. I'm going to go ahead and we're going to change our y-intercept. Okay. For g of x, our y-intercept is at -4. This is going to be our b value. So our y-intercept is going to come down here to -4. Now our slope is still the same. Our slope is still 1. So we're still going to do 1 over 1. And just to give you a heads up, on this lesson today, this video, we're not going to change any of our slopes. All of our slopes are going to be 1. We're just going to change our y-intercepts. And look at what happens from the parent function to the new function. Okay, so here is my g of x function. Okay, I'm going to label that as g of x. All right, so if we take a look at this, you will notice that our y-intercept went down 4 units. And if I look at any other point on the line, you'll notice that every point on the line went down 4 units because the entire line just shifted down 4 units. Okay, so we're asked us to identify the translation. It shifts down 4 units. Okay, now if we write this transformation equation in terms of f of x, if we write it in function notation, all we're going to do is we're going to say g of x equals, we're going to write f of x, and then our translation was down 4, so down 4. Okay, so we're going to have a -4 for our translation. Okay. We take a look at example 2. Okay. Example 2, again, we're going to change our y-intercept. So our y-intercept this time is going to be at +3. So we're going to put a dot at +3. And then we're going to go ahead and graph all our points after that. Okay. Oops, that one doesn't go there. There we go. Once we get all our points graphed, we'll go ahead and connect all our dots. And we want to try and graph as many points as possible. It makes our line a better line, so that hopefully it's a little bit straighter than what I seem to be doing today. Okay. There we go. We're going to label it as g of x. All right. So this time, when we look, our y-intercept moved up 3 units. So did all the other points on the line. They all moved up 3 units. Okay. So when we talk about the translation or identify the translation from f of x equals x to the graph of g of x equals x plus 3, we find that our graph or our translation was a shift up by 3 units. Okay. And when we go to write our g of x in terms of f of x, we're just going to write f of x plus 3. Okay. So what we're looking at is just a change in our y-intercept. Okay, it's changing the y-intercept. It's not changing the slope. But because it's changing that y-intercept, it's moving the entire line up with it. So when we talk about how to describe the how changing the y-intercept affects the graph of the function, then we want to say that it changes the changes we want to talk about how it changes in the y-intercept, move the line up or down. Okay. Up or down. And it depends on whether, if it is a positive change, it's going to move it up. If it's a negative change, it will move it down. Okay. So your vertical translations will change your y-intercept. But notice it did not change our slope. Our lines are still going changing at the same rate that they were changing before. You notice we actually created 2 sets of parallel lines on example 1 and example 2. Okay, these lines are never going to touch because they have the same slope, so they're they're next to each other concurrently, and they're changing at the same rate. They are just starting at a different point. Okay. So let's talk about example 3 here. Our third example, the graph of g of x is on the coordinate plane to the right. Okay, it's already labeled for us. Describe the vertical translation of the linear parent function f of x equals x to g of x. Let's go ahead and put our parent function on there. Let's go ahead and graph it. Okay, it would make it a lot easier to look at the change if we could see the parent function as well as the transformed function. Okay, so again, I'm starting at my y-intercept, and then because my parent function has a slope of 1 over 1, I can either go up 1 and right 1, or I could go down 1 and left 1 so that I get the correct slope. Okay, so here's my f of x function, my parent function. All right. So then from our parent function to the new function, our new y-intercept is at 0, 3. So we could see that our line shifted up 3. And if we look at any of the other points on the line, we see that it shifted up 3. Oh, I take that back. Yes, no. It shifted up 3. I confused myself for a moment. I thought I was looking at the wrong line. Because remember, we graphed our parent function. We didn't graph the transformation function. Transformation function was already there. So our equation, or describe the vertical translation, it shifted up 3. Okay, so our equation is just going to be x plus 3. Because we shifted up, it's a positive. Now, if we're writing this in terms of f of x, we took the entirety of our function, our f of x function, and we moved the whole function up 3 to get g of x. Okay? If you look over here to the side, how does the coefficient of x affect the vertical shift of a function? So coefficient of x, we normally call the slope. Okay? So how does the slope affect the vertical shift of a function? It doesn't. The slope does not have any effect on the shift. Okay? Slope does not affect whether or not the line moves up or down. The slope will affect how steep it is, but not how far up or down it moves. Okay? All right, so let's look at examples 4 and 5. Now, these are a little bit different. These don't have graphs with them. Okay? This time they want us to write the equation of a function described by the given transformation of the graph of f of x equals x. So again, we're starting with our parent function. And it says that it wants to translate 2 units up. So if I take my parent function and I translate it 2 units up, I'm going to go from x, okay, so there's my parent function, and I'm going 2 units up, so that means I'm going to put a plus 2. So x plus 2. Now, in terms of f of x, I'm going to take the entirety of the original function. I'm going to move it up 2. Okay. So far in all of these examples, f of x plus 2 and x plus 2, they look the same. Why do we write as f of x plus 2 when x plus 2 would do the trick? That's going to be answered with this next example. On example 5, our starting function, our f of x function, is x minus 5. So for g of x, I'm going to take that entirety, that x minus 5, and that tells me that we're going to shift up 10 units. Okay, so we're going to plus 10. Okay, now normally we don't write linear equations as x minus 5 plus 10. We want to look at one y-intercept. So what we're going to do is we're actually going to combine the negative 5 plus 10. So we're going to get g of x equals x plus 5. Because when we do negative 5 plus 10, we get plus 5. However, if we keep it in function notation format, f of x is our original function. And we're going to shift that entire function up 10 units. So plus 10. So even though our original function is f of x equals x minus 5, if we keep it in function notation, we're not having to add those two integers. We just leave it as f of x plus 10. All right, guys, that is our lesson for this video for today. If you are in my Algebra 1 class for this school year, you now have an assignment on page 23 in your packet where you are writing equations and you are graphing a couple of these transformed lines. You do need to graph the parent function as well as the transformed function. Guys, you have a great day. I will see you tomorrow, and behave. Bye.